Hi everyone, and welcome to this last day of Copenhagen FinTech Week. We are very happy that you have chosen to watch our research track for the session here at 10 a.m. Today we'll focus on university and industry collaboration and partnerships. So we will showcase you research from the highest level of professors globally, but also who work in Denmark. And the first session that we want to show you is together with Henrik Madsen from the Technical University of Denmark and Jonas Bjarke Jensen from Copenhagen Economics. They have both worked very hard in regards of energy optimization within windmills and electricity and so on, but also in how to use and apply this research within the financial sector. And Henrik will show you the research they have done in regards of energy optimization of buildings. Jonas Bjarke Jensen will show you how this research can be applied to the financial sector and used for green mortgages and how to build an efficient and green financial system. Thank you all very much, and we look forward to hear your opinions in the chat in the live discussion. And we are starting with Henrik's pre-recorded video.
Hello, my name is Henrik Madsen from DTU Compute, that's Applied Mathematics and Scientific Computing at the Technical University of Denmark. I will share my screen with you for this FinTech presentation. I'm glad to team up with Copenhagen Economics on suggesting methods for building a green future for finance. And actually, this talk is related to buildings, how we can use data-driven methods for improving the energy performance of buildings. Energy performance buildings has been characterized for many years by labeling. But it has been well known and for many years that the energy labeling as it works today doesn't really work. The fact is that two independent experts, which are supposed to provide a label, can end up in giving rather different results. However, some years ago, we didn't have the data we have today, but we think that today we should try to use the data and meter readings we have available. Some of the problems for the experts visiting a house for providing an energy label, for instance, is that he's not able to see the hidden layer of the buildings. Here is an example where we actually have two builds of exactly the same wall construction. For the one on the left, the heat flow through the wall is rather high compared to the wall on the right. And the theoretical U value, which is related to insulation, is 0.16. If it's done in a nice way, then we end up, as we can see on the right, with U.0.21, whereas we are able to see in some cases that the heat loss can be 4 or 5 times higher. This fact that the energy consumption of buildings in many cases are way higher than predicted is well known. This is an investigation which was carried out in the UK with 18 different dwellings, and we can see that in many cases the measured heat loss was twice as large as the predicted heat loss. We also know that previously the support scheme for energy efficiency and providing financial support for renovation of buildings and so on has been based on tables. It was concluded 3 years ago by a report from the so-called Rigsrevision in Denmark that this support scheme doesn't really work, and a new method has to be introduced. What we suggest are data-driven methods which will lead to evidence-based and automated procedures. And our procedure, which we suggest, consists of three steps or three elements. One is a screening element in which we can find the buildings which has the highest potential for building renovation. The second one is methodologies for providing automatic suggestions on how to upgrade the individual buildings. And number three is methods for verification of the obtained improvements after, for instance, an renovation project. We do also suggest to introduce data-driven methods for energy labeling, which can be done automatically in the cloud. So it's much more easier and will be way cheaper for the house owners. One important element in our procedure is that we are able to take the metadata and separate them into something which is due to hot tap water consumption and another part which is due to heating. And the part which is due to heating can again be separated in a part which can be linked to the characteristics of the house, and another part which is linked to the user behavior. Let's consider how we are using the metadata for energy performance characterization. Let's first look at the options for energy performance characterization. One is, of course, just the energy labeling. Another one is estimation of what we'll call UA value and GA values. UA values say something about how well insulated the building is, and the DA values say something about how well the windows are designed with respect to take advantage of the solar radiation, so it's related to the solar gain. We will also be able to provide a more detailed energy signature of the building, which expresses different characteristics, how sensitive it is for wind speed and things like that. And furthermore, we'll be able to characterize the dynamical characteristics of the building. And as an important part of that, we will be able to estimate the time constants of the buildings, which are very useful for future smart control of buildings. These are some examples from Sønderborg, where we analyzed something like 50 houses with district heating. And due to GDPR, we just have the numbers on the left. One number is related to a house. And then for the only data we have here was frequent meter readings, and then meteorological data, outdoor air temperature, solar radiation, and so on from the airport in Sønderborg. I will not go into the detail here, but what we can notice is, for instance, we are able to estimate a characteristic indoor air temperature for the individual families or individual buildings. We are also able to see that this WEA express how sensitive the building is for wind speed coming from east, south, and west. And in this limited amount of time when we had the data here, we didn't have any wind from the north. So that illustrates one of the drawbacks from the data-driven methods, that if we don't have data, we're not able to come up with numbers. What we can see from this table we can see a lot from this table. One of the things we can see is that this building has a much higher consumption when the wind comes from the west than when it comes from the south. And if we look at the drawing of the building, it seems to indicate that there could be some problems with a door or window which is untied on the western side of the house. So there are a lot of perspectives in this setup and in this and using of frequent meter readings. One is, of course, to find the most problematic buildings by the screening procedure, as we mentioned before. Another thing is automatic energy labeling or digitalized energy labeling. And then if we zoom in on the individual houses, then we will be able to see from tables like the one we just saw, should we replace the windows? Should we put more insulation on the roof or in the walls? Should we tighten the building in general? And so on and so on. And with the time constants, we are also able to uh, provide information which can be used for a better control for the heat supply. This is just to show these data are from Middelfart in Denmark. This is just to show three different houses with the time constants, and that's houses where we have a night setback. What we can see in general is that buildings are characterized by temperature dropping rather fast, and then later on a little bit slower. So in general, a building need two time constants in order to characterize the dynamics. And this clustering of, I think we had something like, again, something like 50 or 40, 50 buildings in Middelfart. And here we can see that the buildings can be clustered in three different categories based on these two time constants, tau 1 and tau 2. Let us zoom a little bit in on the models we are looking at. The models we have are rather simple model or equivalent models for describing the dynamics of the building. And this shows a building where we will zoom in on the solar radiation in this example. And the solar radiation hits the window, and then a part of the solar radiation is absorbed, transformed into heat, and another thing is reflected, but also something is going into the house. And then we also have heat from radiators and heat loss to the outdoor air temperature. In order to describe the characteristics of this building, we set up an equivalent simplified model. And this model contains some important parameters or states. Some of the hidden states, which we don't measure, are the temperature of the floor. This building is characterized by having a rather heavy, thermally heavy floor, concrete floor, but the wall is rather lightweighted. So the thermal mass is represented by the floor, and one of the hidden states are the heat stored or accumulated in the building, which is then stored in this thermal mass. This temperature is not measured, but we can estimate how much is accumulated. Another interesting parameters is the fraction of the solar radiation, which actually, and we call that K, the fraction of the solar radiation which enters the building. And this fraction, if we do an online estimation of that, then this can actually be used to setting up a support for showing when the windows have to be cleaned. And if you have it like I have it at home, I'm the one responsible for cleaning the windows. And before we had this system, I always thought that the system was crystal clear, but my wife said that they were dirty, always claimed that they were dirty. So we discussed it from time to time. But now we just look at the K values, and when the K value is less than 0.6, then I clean the window, otherwise they are clear. It's also evident that even more data, what we talked about so far was just using the meter data, which we have available today in most houses. But if we can have more data from the building, then we can also have more information. And let me try briefly to outline some of the perspectives and also link that to some of the models we are using. So at the first level, we are using just energy use data, like we did before, the energy meter data for total space heating. And then for the weather data, we typically need outdoor air temperature, solar radiation, and wind speed and direction. And this can give, as we just also saw, the heat loss to the surroundings, and the time constants. It can also give heat capacities and the influence of wind and solar radiation, as we just also saw in the table. If we have some indoor sensors, indoor air temperature, CO2 sensors, humidity sensors, and so on, then we can also better guide the people in the house on how their behavior affects the energy use. And if we have also electricity consumption, then we can have even a better and more precise estimation of everything. And today we have both, typically both meters for electricity and, for instance, district heating, which is most common in Denmark. This is just to show one example. I will not go into the details, but these are the models we are zooming into, and which we estimate by our AI methods. And based on the parameters in this model, we can estimate the heat loss coefficient, the heat capacity, and the time constants. I will not go into the details, but I just think that you should see a few equations. What we tend to do is to develop and implement that as a cloud solution at the new digitalization hub for energy systems in Denmark, and this hub is called Center Denmark. Center Denmark is a digitalization hub for accelerating the green transition based on IT, digitalization, communication, and so on. Center Denmark is located in Fredericia, so very central in Denmark and very close to some of the most important players in the Danish energy systems, like Energinet DK, Danish District Heating Association, and some of the important power suppliers like Ørsted and Evi also have their headquarters nearby. What we do at the Center Denmark platform is that we have established a trusted data sharing platform. And here data should be understood as both classical data like numbers, but also software. So we share both software, algorithms, and conventional data. And of course, we put labels on the data and tags, so we are able to control who has access to the data and who has not access to this and this data, and so on. So this is a trusted data sharing platform or economy, you may say. The control room of Center Denmark will look like this. The important thing is that we can zoom in and out, and so we have a spatial zoom functionality where we can zoom in on the individual buildings. We can also zoom out and consider a whole city or just a district of the city and characterize the energy efficiency on all levels. What we do also in Center Denmark is we have created a Unilab.dk consortium, and that's a consortium where we have a number of municipalities in Denmark. I think we have 8, 9 for the moment, and we also have the bigger cities like Copenhagen and Aalborg in this setup, because we would like to test and develop these procedures further and do it in a way so the conclusions are representative and scalable. So that's why we think this concept of Center Denmark together with the Unilab DK setup is an interesting setup. I will stop here. Thanks a lot for your attention.
All right, thank you very much to Henrik Madsen for the talk. So I will then take the solution he talked about further and describe how the solution can be used within financial institutions to promote lending to energy efficient mortgages. So my name is Jonas Jensen, and I'm a senior economist at Copenhagen Economics and is working within sustainable finance and financial economics. So the claim in the presentation, I think there is 2 seconds some technical issue. One moment. All right, here we go. So how can financial institutions contribute to closing the energy efficiency gap? So the claim that I would like to document with this presentation is basically that financial institution can be a driving force in green transformation of the building stock through lending to energy renovation. So hopefully after this presentation you will all be convinced that that is true. First, I would just like to take a step back and just see why is it important that we focus on energy renovation of buildings. So very high level in the EU, buildings are responsible for about 40% of our energy consumption and for a bit more than 1/3 of the total CO2 emissions in the EU. So there's a big chunk of CO2 emission there that we need to tackle in order to transform to a carbon neutral economy. And also looking at the building stock, there is a big potential. It assessed that around 75% of buildings are currently not energy efficient. And the challenge is, of course, to bring the CO2 emission from buildings down to zero to be compliant with the Paris Agreement. So how do we do that? Well, when we talk about energy renovations, we basically look at the same main 2 tracks that the overall green transformation will take place. So the first track is to improving the energy efficiency, so reducing energy consumptions in buildings. There was also some of the renovations that Henrik previously just talked about. The other track, which is equally important, is an electrification of the heating system, including installation of district heating in buildings and installation of smart energy systems. The idea here being we need to electrify the heating production and make it run on green power in order to complete with the green transition. So it doesn't matter if you have a very energy efficient building, if you still have an oil boiler in the basement producing the energy, then you can never be carbon neutral. So both in terms of improving the energy efficiency, which will sort of shorten the distance to when we are carbon neutral, but also making sure that the energy that is being produced is entirely renewable. So the big problem is that household and companies today, they do not conduct energy renovations in any way to the extent that is needed to be compliant with the Paris Agreement. And they don't do that even though it's often profitable for household and companies to do these energy renovations, meaning that the capital cost of lending for an energy renovation are often lower than the savings would be on an energy bill from doing that energy renovation. So households and companies can actually often save money by doing energy renovations. So it's rational, it's profitable for them to do so, but still they do not carry out these energy renovation. And this is what has been denoted the energy efficiency gap. There is simply a gap between how many renovations that household and companies actually are doing and what will be profitable for them to do so. That's obviously a big problem because that means we don't move on with the green transformation in the pace that we would like to. But it could actually also be an even bigger problem in the future if future policy initiatives are sort of increasing the incentive for green transformation, increasing the incentives to make energy efficiency renovations. Well, if these economic and financial incentives have no impact because households and companies do not really respond to these incentives, that makes it an even bigger problem. So the energy efficiency gap is sort of also an obstacle to make future policy initiatives work. And this energy efficiency gap, it's not really new. It has been discussed for at least the past 10 years. And we have also, as a consultancy, Copenhagen Economics, have also made several reports on the energy efficiency gap. So the challenge is sort of well known. And so are, at least on a high level, the reasons for why we have this energy efficiency gap. So I think the most important obstacle is currently that we call it information to consumers, that consumers, that being household and businesses, they simply do not consider making energy renovation at any given point. It simply does not occur to them that there is actually an opportunity for profitable investment for them. So that's if they don't even consider making it, then it doesn't really any other solution matter. So that's like step one, is to make household companies consider making energy renovation. And very much in line with that is that we lack adequate data. That was also a lot what Henrik talked about. We simply don't have the sufficient data to identify which customers is it that could have use of an energy renovation. It's difficult to identify customers, and it's also difficult because of lack of data to verify the impact of an energy renovation after it has been carried out. And then finally, there are too many transaction costs with making an energy renovation. You need to involve a lot of stakeholders when you do so. You need to talk to the bank, you need to talk to the authorities, you need to get a new EPC label, and you need, of course, to talk to the developers or ESCOs that are handling out the renovation. And all these different stakeholders, you need to engage with them quite a lot. So it is quite troublesome, basically, for household and companies to make an energy renovation. So the problem is not so much we don't know what's going on. The problem is we simply need some institutions to take responsibility and make sure that solutions are implemented to overcome these barriers. And this is what I had alluded to. Who could that be? Well, in my view, I think that financial institutions are in a key position to implement solutions that could overcome these barriers for two reasons. The first is that financial institutions have a unique customer contact. Around 90% of all renovation takes place in connection with, or energy renovations take place in connection with other renovations. So we need to have an institution that, so in this space when households and companies say, I want to make a renovation, this is the window of opportunity to impact customers to also make an energy renovations. And since almost all customers are in one way or the other engaging with their bank when they make a renovation, it is obvious that financial institutions could take the responsibility to say, oh, okay, you also have to actually consider making an energy renovation because it will actually be profitable for you to do so. So customer contact is the first reason. The second reason is that financial institutions obviously have the financial capacity to finance the energy renovation. So not only can a financial institution, a bank, recommend, I think you should do this energy renovation, they can also see, and here is actually a loan for you to carry out the energy renovation. So they have the financial means to make it happen. And here, banks can use the fact that when you conduct an energy renovation, the value of the building would increase. That increase in value can actually be collateralized and used as security for the loan to the energy renovation. So in that sense, it really drives down the financial cost. You can say part of the energy renovation is financing itself through the higher collateral value. And obviously, that's only financial institution that has the possibility to exploit that, the increase in value can be used as a collateral. So I hope that you are convinced that financial institutions is the right set group of institutions to overcome the energy efficiency gap. So that brings to the next question: what should actually be done to overcome these barriers? Which solutions are we talking about? The first step one is to get better access to data and to get new data, and this was what Henrik was talking about, the solutions that we're working on there. The idea is then that this new data, new databases can be implemented at financial institutions, and they can be the one to get energy efficiency data on their customers, allowing them to actually single out which of our customers is it that could likely make an energy renovation. And not only can this find out which of the customers is it that should make an energy renovation, they can also use the data to actually recommend which kind of energy renovation should they make. So it makes sense that financial institutions get access to this data and are implementing it in their system. Once they have had that data in, it is of course important to convey that data and that message to customers in a convincing way. And here we are also working with some of the behavioral biases that consumers are finding when considering energy renovations. So it's very important that consumers get very targeted, very clear and transparent information about the opportunities to make an energy renovation. So it could be that as shown here as an example, that consumers get a one-pager with based on the data we have on your energy consumption, we can see that it will be good for you to make an energy renovation. We can also see, for example, that it's on the west side of your building that there is a problem, and it looks like you need to get some new windows, for example, or increase isolation. So this is our recommendation, and actually we already have a loan for you prepared to finance that energy renovation. And in that, we will use the fact that your property will increase in value if you make this energy renovation. So we can use that to collateralize in a new loan for you to make actually quite low financial cost and eventually convey the message that your monthly costs will go down because of this energy renovation. Now, if financial institutions could do that, I think they will make a very convincing argument to many households and companies that they should carry out energy renovations. The last obstacle that needs to be handled is the fact that I mentioned that there was a quite high transaction cost in making energy renovations for household and companies. Here it is, for example, one study showed that up to 40% of the cost of an energy renovation could be transaction cost. So simply the cost of time and money spent on getting approval from authorities, dealing with different stakeholders, all the paperwork that is involved. That takes up a lot of time, and time is also an opportunity cost for household and companies. So an effective way of making it more attractive to make energy renovation is to reduce transaction cost. And there, my hypothesis is that bank could become some kind of facilitator of different stakeholders to facilitate collaboration, to decrease the number of contact points for customers. The end goal could be that banks actually become a one-stop shop for energy renovations. So after you have seen this in one pager from the bank and you are convinced that it is very profitable to do an energy renovation, you more or less only have to say, yes, I want to make that energy renovations. And then the bank already have collaboration with ESCOs, developers, authorities to make all the necessary paperwork to realize it with a very low effort of for the customers. So if we succeed with that, I think that could give an enormous boost to energy renovations. So you can then ask, so what's in it for the banks? Why would they take on this responsibility? Why would they take on all the trouble to facilitate all this? So I think one answer, and perhaps the most obvious answer, is that this is a huge business opportunity for financial institutions. I saw one report saying that the amount of energy renovations needed in the Nordics the next 10 years would be 70 billion euros. So there is a large potential out there for a large business opportunity for banks out there to lend to these energy renovations. But other than that, you can say that financial institution has also to a large degree committed to make energy renovations and to contribute to green transitions. Many Nordic banks have signed up, for example, for principles for responsible banking, where they commit to contribute to green transition. And And I think if you have to look at financial institutions' contribution to green transition, I really think that energy renovation is a key contribution for them. If you look at the needed investments within green transition, often a lot of cases in terms of installation of renewable energy, for example, it is risk capital that is needed, where maybe it's also private equity funds, pension funds, this kind of finance that are needed. But when it comes to energy renovations, it's often can be done with credit finance. It's often credit that is needed. So here I really see a large potential for banks and mortgage institutes. Therefore, it's of course also important then when banks lend out to energy renovations that they do it with a loan product that is taxonomy compliant, meaning that it is officially by EU recognized as being green lending. That will mean that it will officially count towards the green goals that Nordic banks have set up. So it's important in the work that we do to make sure that the mortgage lending for energy innovations are complying with the EU taxonomy. So the process going forward, how do we actually do that? So we are, as a consultancy, currently involved with a European project called the Energy Efficient Mortgage Initiative. It is led by a European Mortgage Federation that has set up a pan-European label to promote lending to energy renovation and has a range of different large Nordic banks as pilot banks, including also several Nordic banks. So that is the initiative on an EU level. In addition to that, we are also setting up currently a Nordic initiative. It's still very early days. We have gathered some different kind of experts, for example, DTU, which is a behavioral science consultancy, Green Digital Finance Alliance, and Henrik that just had the presentation. And we also in talk with some early dialogue with some major Nordic banks and a Swedish fintech company called Hemma. But it's still in early days of trying to set up solutions in the Nordics. So the last question is then, how can fintech companies then contribute? So I have primarily been talking about the solution that Henrik has been making and how that can be implemented in financial institutions. And then the question is then, what is the scope for fintech companies actually to contribute? And I think the short answer is that you know best, better than me. So if you're sitting out there working in a fintech company and you think you have a solution that is exactly what we need in this initiative, let me know. It could be very interesting to hear if you have any sort of idea of how to bring this forward. If I had to go a bit sort of closer to where I could see that fintech companies could contribute, I think we have to look at the solutions, the free solutions that I sketch, where I think in all free solutions there could be a need for technology by fintech companies. So I think maybe the most difficult part of the solution that we have sketched is the reducing transaction cost. So basically making financial institutions a one-stop shop for energy renovations, because that requires a lot of automatic collaboration between different stakeholders that normally do not collaborate. So I think there is a need for a sort of a marketplace provider or some automated processes that make sure that these different kind of approval that is needed and contact of different developers is somehow automized. So that's one option. The fintech company could of course also just take the role as the financial institutions, actually providing lending to companies and households. And we have, for example, this Swedish fintech company called Hemma, which is an interesting case. So they basically lend out only for energy renovations to primarily household, and then they fund themselves directly off the balance of institutional investors. So they are not a normal bank. They are more a fund. They are registered as a private equity fund, getting funded directly from pension funds, and then use that to finance energy renovations in household. So that's, for example, one interesting case of new technology within the financial sector contributing to energy efficient renovation. That was all I had. Thank you very much.